in my presentation, I'm discussing the study, the Pliocene and Eocene, providing the best analogs for near future climates. Okay, so let's look at the study. Okay, so first we have this temperature curve. It's from the extinction of the dinosaurs 65 million years ago, going to the present, and then in the end we have some different climate models who give some predictions of the temperature in the future. In the past, we see some very warm periods like the Eocene, nearly 15 degrees warmer than now. We see like a period called the Pliocene here, 3 million years ago, where it was warmer, and we were not in an ice age stage on the planet. We have the ice age here, we have the present, and then we have these climate model predicting the future. The highest one here is called SCF 8.5. It is also called business as usual scenery or worst case. It's because it is what will happen, predicted, which will happen with pregnant temperature on Earth if we humans fail to do anything to limit climate change. If we just let, like, basically economic decide what we emit and population growth, and just let stuff happen. Then we have the RCP 4.5. In that we succeed in limiting our emissions. And actually, in 2100, in this scenery, the climate forcing peaks at 4.5 watt per square meter, and then just stayed there. So we were quite successful in limiting climate change in this model. You also see why we in this study are interested in the Eocene period and the Pliocene period. It's because they are corresponding to some of the predicted temperatures in the near future. Like in the worst case model, we after a couple of hundred years, we end up in temperatures comparable to the Eocene warm period. And we get fairly fast into 1,000 temperatures. In the ICP 4.5, we are stabilizing around the temperatures in the Pliocene. Let's look at the Eocene and the Pliocene in more detail to understand the climate a bit more. First, I'll just show this graph. It is a graph similar as before, just the scaling is a bit different, just to see the rate of the temperature change, and see that the Eocene was actually a quite spread out period. So this warm phase was actually spread out over 10 million years. And then there was the temperature falling here. And then we have the Pliocene here and the Ice Age phase here. And here we're here now, and then it's the predicted temperature in the future. The colors are showing the how warm it is. Okay, first I will just show how the Earth looked in the Eocene. It was 15 million years ago. It was the warmest period since the extinction of the dinosaurs. Here's a map showing how the Earth looked. You can see India was still floating around here in the Indian Ocean, um, getting close to Asia. So the Himalayas were not there. There was a sea between Europe and Africa. There was also a free ocean between South America and North America. So Pacific and Atlantic were connected. That is, they had this basically the same salinity at this time. Antarctic and South America were touching, or nearly touching. There was a narrow strait. The Earth then was much warmer, um, so much warmer that both Antarctic and Arctic were completely ice-free and probably covered in forest because there was no ice. Um, the sea level was more than 70 meters higher than present. CO2 level in the Eocene are estimated to be 1,000 to 2,000 ppm. In the papers, they say it was around 1,400 ppm. And global mean temperatures were estimated to be around 14 degrees warmer than the present. So you can see it was very different. Here we have the Pliocene, 3 million years ago, before the ice ages. The shape of the planet looks quite familiar. The continents are in place where they are now. But at this time, the Panama Strait had closed, so Atlantic and Pacific were not connected. So there was a salinity difference at that time, giving rise to the present ocean currents. The Arctic were ice-free at this time. There were no big ice glacier on Greenland, and no permanent ice in the Arctic. The Antarctic was covered in ice, but it was warmer. So what that meant is that East Antarctic was covered in permanent ice, but West Antarctic had a fluctuating ice currents. That is sometimes ice that collapsed, and then when it got colder, it would form again. That meant that the sea level this time was much higher, actually 25 meters higher, and was fluctuating a bit in accordance with the formation and collapsing of the West Antarctic ice sheet. The CO2 level in the Pliocene was similar to today. So it is Pliocene is a very interesting period to study because it has many similarities today, and the planet was basically similar. In the study, we look at two models. We look for the ICP 8.5, the worst case model, the business usual model, and look how these different climates spread on the Earth. We see like after 2050, as shown this, the Pliocene climates, which are shown as orange, they get quite spread. And if we go 50 years more into the future, in 2100, Pliocene is like dominating climate type, and Eocene climate type is starting to appear on our planet. If we go 100 years more into the future, like 200 years from now, we see that the Eocene climate analog types are dominating on our planet. So basically, we have a warm Earth. We will get a warm Earth 200 years from now, of climate very similar to the Eocene. That is climate up in this phase. So that is a much warmer climate. That is not the continent will move, just that the poles should be ice-free, both Antarctic and Arctic, and that is corresponds to a 70-meter higher sea level. Okay. Here you see how fast it happens. So yeah, then in the B, we are looking at RCP 4.5, where we succeeds in limiting our emissions. See, from 2050, Pliocene climate analogs gets dominating on Earth, and then it stabilizes from 2100 and on to the Pliocene climate types as dominating on Earth, and we never really get into other climate types. So this model is, of course, a more safe scenery because we will reach climate types which are more similar to the present, but still, as we saw before, it's a very different planet. It's much warmer. Okay, so let's discuss the study. First, is it relevant to use the worst case business as usual scenery RCP 8.5 for prediction of near future climates? In my opinion, yes. In the year 2021, we are still following the carbon emission scenery from RCP 8.5 closely, and there's no prospect that this will be changed in the near future. So understanding the possible consequences of what is already happening is, for obvious reasons, very relevant. Is RCP 4.5 a good and safe carbon emission scenario to aim for? Well, that depends. But first, getting us to the RCP 4.5 path is an extremely difficult task, demanding unseen regulation and political change on a global scale, implementation of high carbon tax, forestation, land use change, carbon capture. But is it enough? Are we okay? Are we safe? In my opinion, probably not. Getting to Pliocene climates in only 100 years is an unseen fast temperature change, putting both our environment and our own civilization under extreme stress. As we saw before, the Pliocene was a very different planet. The sea level was more than 25 meter higher. There was ice on the Arctic, but it was a bit unstable ice on the West Antarctic. So there were ice, the sea level could fluctuate quite a lot. And with 25-meter higher sea level, basically all of major cities of our civilization today would be flooded. Lastly, archaeological evidence. From archaeological evidence, we know that both in the Eocene and the Pliocene, we had prosperous and diverse life on Earth. So, what is the problem in returning to these climate types? Yeah, the big difference from then to now is that the temperature changes in the Eocene and Pliocene happen very slowly, giving life time to adapt to the changes. The speed in the temperature change, which is happening now, is several orders of magnitude faster. The only events in paleodata with similar speeds of climate change is from the big extinction events, usually because of impact events or flood basalt eruptions. So, in my opinion, yeah, even if there can be good life on Earth, when the planet is warmer, getting there in a short amount of time is probably not a good idea. You can see here the Eocene is quite spread out period, not like something which happened like and the same for the Pliocene. So I mean, it doesn't look like a safe bet for me. Lastly, here's a picture I found on the internet of which kind of animal life and how our planet could look in the Eocene 50 million years ago. Thanks for your attention.